Who can tell me how many degrees that blue angle is? Anybody? Yes, sir. 140. Very good. And we'll talk about that in just a moment after I connect my pad. Very good. We're going to be talking about angles today. Now, we're actually not going to use protractors in here because I don't have protractors. But if you were to use a protractor to measure an angle, it's about, now sometimes the arrow will be going out this way, so you have it like this and open up. That's why there's two sets of numbers. If you start here and open this way, you'll use the outer ring. And if you start here and open this way, you'll use the inner ring. So in this case, you use the inner ring, and it's 140 degrees. 140 degrees is what you should have gotten for your DOM. So, questions on the DOM? Here we go. Okay, here's the first piece of vocab that if you record notes, you may want to get this in your notes. Thank you. Let's put that in there. This is 1.4. 1.4. So an angle is made up of two sides and a vertex. The vertex just dictates where it's a corner. So if you're ever helping your parents like measure a room or anything, you should like just throw them off. Be like, hey, you're going to start at the vertex? Like, what are you talking about? That'd be kind of funny. I don't even do that, so you'd be like at a new level of nerdiness, but I think it's fun. So anyway, two sides and a vertex. Those sides, well, heck, just look at the sides. What geometric shapes do they look like that we've dealt with before? Rays, starting at A, going through C, going through B. So sure enough, this particular angle, its sides are made up of ray AB and ray AC. Now, when you're labeling an angle, in fact, I may be jumping the gun. This might be in the next, oh no, there it is. When you label this angle, because there are going to be times where you're going to be looking at a picture with a whole bunch of angles, and I say, which one has the vertex that blah, 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 or something like that. And you're going to need to tell me which angle that is. You know, like before you had like segment AB, it was AB with a little segment sign over it. Well, for angle, you want to choose this or this. Not this one, and I'll tell you why in a second. This is angle and this. Do you have a rotating figure? You have that? The free cap? Yes. Looks like we're going to be playing trade a book for one. Anyway, angle BAC and angle CAB. You basically just pick any points outside the vertex or opposite sides. And that's how you're going to lay angle BAC, CAB. Why don't you think we could just call this angle A? Well, I will give you a hint. Well, I won't. I'll just show you. What happens if we angle this angle, angle X? What's the problem naming one of those angles, angle X? Yeah, exactly. It's a mutual vertex. It could be that top angle. It could be the big angle. It could be the small angle. You wouldn't know. That's why you need the full 3 letters to name an angle in this class. Your book may on occasion just call something like angle A or angle B, but that's a bad habit to get into. So I'm going to require we give them 3-letter names whenever possible. So, I accidentally covered the number. The three angles here. And they all have two names you can call them by. The three angles are WXY, the top one, which could also go by YXW. Notice, what's the only thing that these two angles have in common? As far as like in the same order? X is in the middle. Always make sure the vertex is the middle letter. The middle letter should always be the vertex. Always. So there's WXY, there's XY, or YXZ, which is the small one. And what's the last angle? We just got that one. WXZ. That's the entire angle. So there's WXY, YXZ, and WXZ. Those are the three angles in this picture. Questions about labeling and finding angles? You don't have to write this down, because I'm pretty sure most of you could probably just figure this out. But like we talked about in the DOM, a protractor can be used to measure an angle. When I ask you to, tell me how many degrees that angle is, what you're doing, you're telling me the measure of that angle. That's what you call it. And the way you're going to write that, now you could write it out in words, the measure of angle WXZ is 32. But the easier way to do it is just shorthand like this. It says that the measure of angle WXZ equals 32. Okay? I'm going to beg that you do not leave off the M, because there are going to be other things we're going to be setting angles equal and congruent to later on. So if you're ever going to be talking about its degrees, please put the M on there. Measure of angle WXZ is blah, blah, blah. And of course, they'll always be in degrees. Okay. You do not have to put this postulate in your postulates and theorems section, but once again, I just thought I'd put it on there, but it's kind of a no-brainer. And it is that if you put a protractor over an angle, then that protractor will give you the measure again of that angle. You kind of already knew how to do that in the DOM, obviously, so I'm not going to beat that to death. And I don't even think you'll really need that much in this class. But I still thought I'd show it to you. Alright, classifying angles. There are four kinds of angles. There are acute angles, right angles, obtuse angles, and straight angles. Those are the only four kinds. Acute are the smaller angles. The easiest way to keep that different from obtuse, because sometimes people get acute and obtuse mixed up, are, think about dogs. You wouldn't say it's a cute dog if it was like over your head. Those are those little bitty dogs are the cute ones. The smaller the cuter. Acute angle is a small one. Obtuse angle is one bigger than 90 degrees. Right angle is something that equals 90 degrees perfectly and will always be denoted by this little box here. And a straight angle basically forms opposite rays. If it forms opposite rays, then it's a straight angle and it measures 180 degrees every time. Why don't you think it's necessary to tell you about angles that are bigger than 180? Kind of an outside the box question, but yeah. Exactly. If you just look at the other side of it, right? Yeah, exactly. That's like, why can't you ever fly more than 12 hours away on an airplane? Because why wouldn't you just go the other way around the world? Same kind of difference. The reason I'm not telling you about angles bigger than 180 is because you could look at the other side of them and it would be less than 180. So that's why there's only the four kinds. And they're all going to be 180 degrees or less. Question. Alright, we're just marching right through it today. Use the diagram to find the indicated measure. Really, more than the protractor, I want you to know how to find those particular angles in the picture. Take a look at them. I'll call on people at random to give me those measures. I'll call on people at random. biggest thing is, can you find those four angles? Notice they all have the same vertex. All about the starting point and ending point of those points. Let's see. Who's going to start out picking on this? Jasmine, what is angle, the first angle, KHJ? What's the measure of that? Let's see. K, it is acute, and what's the measure of it? Very good. That's right, about 55. Oh, that's right, I haven't been on for but these are in your book, which I noticed you noticed. That's very good. Good. What about angle B, Elon? I mean, not angle B, but question B. GHK, very good. And what kind of angle would that be? Wow, very good. We'll move right on. If you have any questions about any of this stuff, just please ask. Donovan, what do you think? Part C, angle GHJ. Very good. And what kind of angle would that be? Yeah, 3 for 3. And Starla, why don't you take us home with number 4? Or part D, I mean. GHL. Well, G, H, L. That's how you tell what angle it is. So it's this one. And what kind of angle does that look like? Of the 4 we just talked about. Maybe you can elicit the help from one of your desk mates. What do you think? Nice and loud. I don't care who says it. Somebody back there. What do you think? I can't hear you. Blake. It is. Very good. If it forms a corner like that, a sharp corner, it's a right angle, and it is 90 degrees. We need to make sure we know that next time. Questions? Okay, name all 3 angles in the picture. You don't have to write this down. We can just talk about it. Name all 3 angles and tell me which of those 3 angles by the label is the right angle. I'll just have one person answer all of this. I'll give you a minute. Elijah, you want to tackle it? Go. Okay. Is the right angle. What are the other 2 angles in the picture? Excellent. Well, you got 2 of them. PQS is the right angle. PQR is an acute angle. Well, why can't you say it's the acute angle? Like, because the other one's acute too. This one's acute and this one's acute. And that would be RQS, is the only one you didn't get. Yeah, there's not always going to be just one acute or one acute. In fact, there could be 50 acute all right next to each other. So, they're both acute, and the right angle is PQS. That's the right angle. Question over this vocabulary? Let's see. Now this you do need to put in your postulates and theorems section. You do want to put this in your postulates and theorems section. That's what you're going to need for your bonus proofs later on. Now, you don't have to write these down verbatim. You can put them in your own words just so you know what they say. as long as later on, when we start working on proof, you know what this angle is, postulate 4, and you know what it allows you to do in adding angles together, that's really all you need to have in your notes. You're never going to need the verbatim word. You just need enough in there to know exactly what it is. So here's what this says. And mathematically, it's actually a fairly basic principle. If this angle, let's call it 40 degrees, and let's say this angle is 30 degrees. This may not be the scale, but I'm just making this up. What's the entire angle? Ooh, nice and loud. 70. Yeah. That's all the angle addition postulate is. If two angles are adjacent to each other and they're kind of connected along common vertex and side, then you can just add them together. And that's your angle. So, that's all the angle addition postulate is. Are there any questions about the angle addition postulate before we look at an example? Given that the measure of LKN is 145, yes sir. Oh yes, sure. Sure. Also, just a reminder for the future that everything that we're doing is in your book, so you'll always have that of option to go back and find it there and write it down. FYI. Okay. I'm sorry. Do I need to leave that up there a little bit longer? Okay. If LKN is 145, find the measure of LKM and MKN. Now, the hardest part of this class is when people get things like this, they can't. They think, what do I do? Do I set it equal? Do I add them together? What do I do? And oftentimes, if you don't look at the equations themselves, don't even look at the 2x plus n and 4x minus 3. If you just look at the problem in its word form, you can usually figure it out. Now, LKN. Which angle is LKN? Yes, the big one, the obtuse one. LKM and MKN are the smaller ones, correct? Now, don't look at the numbers, don't look at anything in blue. What is a safe thing to say? LKN, what's a safe thing that we could say about the other two angles in respect to LKN? I'm sorry? It might be. We can't assume that. It might be. We can't assume that. What's something we can confidently say about these three angles? Yes, ma'am. Yes, that's true. Yes. Yeah. Angle addition postulate. These two angles added together equal the big angle. That's something that we can assume because they share a common side. So let's just think about that. If the two angles can add together to equal the big one, then that's how you're going to set up your equation. Logic your way through it, and then the math will seem a little bit easier to you. So what we're going to do is we're going to add those two angles using the angle addition postulate. We're going to add up the smaller one to equal the big one. So, we took 2x plus 10 plus 4x minus 3 and set it equal to the total of 145. And then it's all about like terms. 2x plus 4x, 6x, 10 plus negative 3, 7. So 6x plus 7, subtract the 7 to the other side, subtract 7 from each side. What do we do now? Divide by 6, and you get 23. Are we done? No. The question asked us for the actual measure of the angle. So we're going to take this, and we're going to plug it in here and here. And that will tell us the measure of those angles. So we plug 23 into 2x plus 10, got 56. Plug 23 to 4x minus 3, got 89. And those are your answers. I think that's about as far as it's going to get today logically. Again, the key to how you set up the math will be in the directions. The directions are your friends. Questions on that problem? Let's see. All right, try these two. Try to find the measure of both of those, and I'll come around and assist. Actually, let's do it like this. This half of the room, these tables, you guys work on number 4, and I'll pick on one of you to tell me the answer. And you all work on number 3. And I will pick on some of you. So half of you do number 3, half of you do number 4, and we'll discuss. If you have any questions, raise your hand. You're more than happy to help. Stacy, you're looking pretty confident. You think you know how to do this? All right. Tell me how to set up number 3. Tell me, what did you do first? So you added them together? Okay. 10x minus 5. I don't know why I wrote it so big. Let me scoot it down. 10x minus 5 plus 4x plus 3. What did you set that equal to? Y 180. Straight angle. Very good. There was the key. Straight angle means it equals 180. So what did you get? Right here. Excellent. Then what did you do? Perfect. Then? Perfect. Then what did you do? $55. And did those in fact add up to 180? Then you did it correct. So she plugged 13 in there and there. Yes, sir. Dude, however you get the answer, that's fine with me. You can take whatever shortcuts you can find, and I applaud you for finding those shortcuts. That's kind of the fun part about math, you know? Those are the best video games. The ones that like you can find the little shortcuts, the little like guns behind a bush. Well, not promoting violence here, but you know what I'm talking about. That's the best part about math, is finding those little shortcuts. So by all means, if you find it, take it. There was a movie. We don't have time for this right now. Okay, number 4. Elijah, you want to tackle it? All right. Well, how'd you set it up? Equals Y90. Right angle was the key. Then what'd you get? Perfect. Then you plugged that in for the x's and got what? Which did that up to 90, so you knew you did it right. 29 went in here and here, and very good. Couldn't have done any better myself. Questions about anything on the board? Mostly we're done. There's only one last thing we need to talk about, and that is, well, this doesn't really count, but I'll go ahead and tell you about it. This is kind of a small little thing. The same way segments are congruent, angles are congruent. Now, you might be thinking, again, what's the difference? Remember, equals, you're using numbers. Congruent, you're using objects. If I'm saying that they have the same number of degrees, they are equal. Their measures equal, but the angles, the physical angles themselves, you would say are congruent, which is equal with a little squiggly over it. That means congruent. So congruent angles are angles that are equal to each other. Now, before I even go any further, if you are told or given a way to find out that two angles are equal, what do you think you do to solve them? If you're told that this angle equals this one, let's say this one is x and this one is 70, what do you think you do to solve for x? If two things are equal, then what can you do with their values? Well, that's what we were doing, but if they equal, hence I'm saying the word, if they equal to each other, what should we do with their values? Set them equal to each other. If they are equal, then set them equal. Normally, the vocab that you're using on one hand will match what you need to be doing in your problem. That's why I keep hammering this thing home. Oh, but as it turns out, I'm not even to where I thought I was yet. Thing you need to notice in this picture, see how they both have one loop? Matching number of loops will tell you which angles are equal in a picture. That's how you denote them. So, in this picture, and we can just talk about it, identify all pairs of congruent angles. Now, when you have just one shape like this, when you have just one shape with 5 vertices, or however many vertices, this is the one time that I won't be angry if you just give me a one-letter name for the angle, for obvious reasons. So, which angles are congruent in this picture? Second, P and S, because they both have one loop, and what else? P and O. Exactly. Those are the pairs of congruent angles in this picture. P and S and P and O. In the diagram, if PQR, if this angle is 130 and QRS is 84, I think it's easier if I just write these in. Now, is this a triangle? No. So these will not have the same principles of a triangle, so it may not add up to 180 or whatever it is you've learned in the past. So, anyway. This is what it says. It says if PQR is 130, QRS is 84, and TSR is 121, find the other angle measures. Well, all you have to do is find its matching loop. Andrew, what would angle T be in this picture? What would this measure be? Angle T would have what measure in this picture? 121. Very good. And what would angle P be? It's actually an 84 with a degree sign. My degree sign was way too big, but you're right. 84 degrees. And that's all you had to do there. Find its counterpart, set it equal. Only way this could possibly get harder was instead of giving you all these nice and fancy numbers, if I had been like, this one is 2x plus 7, and this one is 3x minus 16, but because they equal, what am I going to do with those? Set them equal. Very good. If you're saying vocab on the left hand, then that's what you need to do in the right hand. All right. Now, bisector. An angle bisector. This is one of the more key words you're going to learn all semester because it's going to come up again and again and again and again. And it's never going to change in definition. We learned what that was yesterday, but we were talking about segments instead of angles, but it still means the same thing. Yesterday, if something bisected a segment, what did it do to that segment? It cut it in half, which means each of the pieces were what with each other? They were equal. Now, where do you think I'm going with this? If something bisects something and makes its two pieces equal, what do you think you need to do with their pieces? Set them equal. Very good. So anytime you see in the direction such and such bisects that angle, or this is an angle bisector, you see the word bisect, then your brain should be kicking another part of your brain into thinking, I need to be setting something equal somewhere. So here we go. In the diagram, YW bisects XYZ and XYW. So YW bisects that angle. If XYW, which is this one, is 18, what is XYZ? 18. That's it. Now that one, very straightforward. What if, let's take it up a notch, and this is probably on the next slide, but I'm getting carried away. If the whole thing was 50, what is each of the pieces? 25. Bisect is an extremely helpful word if you remember what it means. All right. Ooh, we get to draw. Oh, this is the last slide, too. That's kind of sad. Just kidding. It's not really sad. Okay. Angle MNP is a straight angle, which means it is, how should I draw this? That's right. Like an opposite rays. We'll call this M, call this N, and we'll call this P. NQ bisects MNP. So Q. And we know that this angle and this angle are equal, right? Because it's bisected. You're taking away my thunder. Draw MNP and NQ. Check. Use arcs to mark the congruent angles. Check. And give the angle measures. Now, Blake, how did you know they were right angles? No, I did not draw those right angles. That is a loop, not a box. How did you know? L shape. It could be 90.1 degrees. How do you know? Positively. There you go. You're right on all counts. But the way you have to concretely know, a straight angle is 180, and it was bisected, and which means cut in half. So if you have 180 and it's sliced in halves, then each of the angles is. Now, once you've proven it's 90, then then you can put your boxes in there showing that I am confident that these are 90 degrees. See, now that's a classic. We're not to these yet, but that's what a proof is all about. A proof is all about how do you know. You could know he was 100% positive they were 90, and he was absolutely correct. But a proof, which we're not to yet, but this is I'm setting the foundation. A proof is about telling how you know. So, for instance, on this one, if I were to ask this as a proof, prove to me that a straight angle bisected forms two right angles, you have to say, well, by the definition of a straight angle, it's 180 degrees, and by the definition of bisect, it cuts it in half. And I'll show you a little thing. Believe it or not, there's even a step for, and by such and such property, which I haven't taught you yet, we know that 180 divided by 2 is 90. And then by the definition of right, yeah, they're kind of lengthy and seem like redundant. But hey, you ever watched the trial on TV, which I bet none of you have because they're boring? That's all of them always do. Like, I can prove this is a gun. How do you know it's a gun? How do you know that sound was a gun? That's what trials are all about. They're ridiculous. People get called innocent all the time in these obvious trials because they forgot to prove one stupid little thing. Well, how do you know he loaded the bullet that shot the guy? Blah, blah, blah. Anyway, there's your time.